All right, so I want to jump in and take a look at this practice test and make sure you guys get solutions. Couple things I would change. I don't like how it says find the change in gravitational energy, so I'm just going to change that to find the gravitational energy. And I'll go ahead and just kind of cross this out. So things that are really good to know, you've got to get your units learned. So when I say 2.0 kilograms, you should immediately think letter M for mass. 4.0 meters, you should immediately think H for height. One number I'm going to give you is I'm going to give you G, which is 10 newtons per kilogram. And that's the same as 10 meters per second squared. So I'll actually give you that constant on the test. So when I ask you for the gravitational energy, you're going to grab the gravitational formula as m times g times h, and we'll put in 2 times 10 times 4, which is going to end up being 80 joules of energy. And then for number 2, we have a large car. It's got a kinetic energy of 40 joules, so I expect you to identify joules as energy. Its mass is 10 kilograms, and we want to know its speed. So we're going to go ahead and I'll write EK is 1/2 mv squared, and we'll plug in our numbers. So 40 equals 1/2 times 10 times v squared. V ends up being the square root of 8, which is about 2.8 meters per second. Now this last one's a little bit trickier, but I absolutely feel completely justified in giving you a question like this. The fact remains that I know you've had at least a year of algebra. And this kind of a question really involves using the energy formula and a little bit of your knowledge of algebra. So although you haven't seen something directly like this, notice the note I put here. I reserve the right to ask you questions that have not strictly appeared in class, but do test you on information you've learned. And this is a perfect example of that. So we don't have a mass, and since we don't have a mass, we're going to leave the mass as a variable m, and we're going to see what happens. So first, we have a kinetic energy at 10 meters per second equal to 1/2 mv squared. I don't know what m is, so I have to leave it as a letter m. I don't know why students insist on removing letters or setting it equal to 0 when there isn't a value for it. Leave it as the letter m, and it's an unknown, and it needs to stay there. So when you multiply all this out, you're going to get 50m for EK at 10 meters per second. And then EK at 20 meters per second is going to be 1/2 times the letter m times v squared. That's going to be 1/2 times m times 20 squared. And that ends up being 200 m. Now when they say compare, this is another word for ratio. So we're going to take EK at 20 divided by EK at 10, and that's going to be 200 divided by 50, and that ratio is just 4. And you know what? Let me say that a little bit more carefully. EK at 20 divided by EK at 10 is going to be 200 multiplied by m divided by 50 multiplied by m. The m's cancel. You get 200 divided by 50, and that's 4. There are no units on this because it's a ratio. Another way you could write this is you could write this as 4 to 1. I do want you to simplify if you get a fraction, though. Okay? So again, this isn't something we strictly did directly in class. However, it tests you on skills that you've either learned in algebra and in physics, and I absolutely reserve the right to do that on your test, so do expect at least one problem like this. We're going to take a look at questions 4 and 5 in the next video.